Okay guys, welcome again to class and we are continuing with proving the kinetic energy formula. Yesterday we did a video on how to prove the same kinetic energy formula starting from the third equations of motion. Based on request, we want to now look at how we can derive the same equation or the same formula by the use of starting from the second law of motion. So actually we want to show, let me have this down as we do that. So we want to show that kinetic energy is given by a half mv squared. Right, so let's look at it from the second law of motion, which is relating us to the law of the linear momentum, and we have talked about it in the previous video. So from the second law of motion, we know that F is equal to ma. So call this your equation 1. F is equals to ma, where F is the force that is measured in newtons, m is the mass, and we have simply a as acceleration due to the gravity. Now, what is the work done by the force? The work done by the force, W, is going to be given as a kind of the space. The work done will give us, let's take a scenario like you have a cylinder or so, and you want to determine how far or how the length is. If I draw a Cartesian plane and want you to find the area under that particular graph, you can actually integrate. So what we are going to do if we want to start from the second law of motion is to integrate the work done. So the integral now of the force in respect to x dx, and we know what is force in this case. F is equal to ma, so we will simply integrate the work done to be the integral of force, but now it is ma dx in respect to x multiplied by dx. So you can call this equation 2. From here, I want to believe that you understood the basic laws. These are just the basic calculus, and I want to believe that you understand how to integrate a certain function. From what we did yesterday, we did not integrate because I simply had started from equation 3 using the equations of motion. But based on the request, we want to now integrate. You know, if you are in Nairobi and you want to come to CBD, and maybe you are in Rongai at Masai Lodge, you can decide to come through Bomas of Kenya, or maybe you want to go through Kiserian. Whatever you decide is your decision. All we want to see at the end of the day is that you show that the kinetic energy or the work done of the system is a half mv squared. So that's what I'm actually going to show you, how we can actually go through Kiserian, connect to Ngong, maybe Karen, and finally we will be at CBD, and we can decide to do what we did yesterday by simply connecting through Bomas of Kenya, and we are already in CBD. But you can decide to go the long way like the way we are now. So the work done will be the integral of that force which is given by ma in respect to x. But we know what is acceleration. So acceleration is simply dv dx. dv dx. Right. So it is dv dt. Sorry about that. So this is dv dt. That is the change of velocity in respect with time. And if acceleration is dv dt, what exactly is v? So v is going to be equal to dx over dt. Now we have to apply chain rule here in order for us to integrate this. So for us to integrate this by chain rule, we know that acceleration is going to be given by Vx. Acceleration is going to be given by, just a minute, this is dv dx. So we have dv dx, multiply this by dx dt. Yeah, so now by integrating, we are going to have if I have acceleration, this will be v dv by dx. I want to believe you understand how to do basic integration. But we know that f is simply ma, right? So if f is ma, by putting this in our integration, we will have m into v dv by dx. Good. So from equation 2, we are going to have, from equation 2, we have the integral of m v dv in respect to dx, which represent the work done of the system. Upon integrating this, we will simply have integral of m v dv. Right, so the work done in this system is simply m v squared over 2, which can be simplified as a half mv squared. So the work done is nothing but the kinetic energy of the system, which is equal to a half mv squared. Proved. So this is what you are supposed to do, guys. If you like to go the integral way, you can simply show this, or you can also start from the third equation of motion.